Another type of Pythagorean theorem problem involves finding the slant height of a square-based pyramid, and that's what you see in front of you. This is a square-based pyramid, and what does that mean? That means you have a pyramid shape, four sides that are triangles, the base of which is a square. And the height of a pyramid is the distance from the center of the square, the center of its base, to this vertex here. The slant height of a pyramid is the height of one of the triangular faces, and that is different than the overall height of the pyramid itself. And the slant height, as you can see, is the red line, and that is the height of the face. And if you take the height of this face, and you go to the center of this base, you can see that if I could draw a line from the center of the base up to this vertex, what I would end up with here is a right triangle. The right triangle would be formed by the height of the actual pyramid, a line straight down, and half of the distance of the base from here to here, and the slant height. So those three elements. And I'm going to show you a problem in which we're asked to find the slant height of a square-based pyramid. Hang on. All right, in this problem, we're asked to the nearest tenth, what is the slant height of the square pyramid? And as you can see, this is a drawing that illustrates what we looked at on the model earlier in this video. And we are given the height of the pyramid here, and we're given the distance of the entire base. We'll get back to that in a moment. But you can see that from the vertex of the pyramid to the center of the square base to the middle of one of the triangular faces, and then the slant height would form a right triangle. All right, so we're asked to find the slant height. And the slant height would be this from here to here. And as I said, it's a right triangle, so you know that you can use the Pythagorean theorem. A squared plus b squared equals c squared. All right, well, let's start with A. I'm going to say that this is A at 13.6 squared. And what am I going to use for b squared? Well, it seems that 18.2 is what most people would use, but that would be incorrect. This 18.2 is the distance from here to here. And I need the distance from here to here, which is half of this distance. So half of 18.2 would be 9.1 squared. And that will equal c squared, and c will represent the slant height. And of course, once again, I am using a calculator here, and I would find out that this would be the equivalent of 184.96, and 9.1 squared would equal 82.81. And this is all in centimeters. That would equal c squared. And I'm going to slide this up so that you can see the rest of my calculations. The sum of these two numbers is 267 and 77 hundredths. That equals c squared. And I'm going to take the square root of these numbers so that I can find out what c is and fit it all in one page here. And I'm just going to slide up just a tad more. And I would find out that rounded to the nearest tenth, c, the slant height, is approximately 16.4 centimeters. And once again, remember, the key thing to remember in these drawings is that when you're given the length of the base of the square, the leg of the triangle is going to be half of that distance. That's 18.2. From here to here is 9.1.